About, yeah. So, hello everyone and welcome. Today I'm delighted to introduce you to two guests, actually. One is Ewout Nas, researcher at the Amsterdam University of Applied Science, more precisely at the Center for Market Insights. His research focuses on the use of service robots in the retail sector, but they also include human-computer interaction, AI, and data analysis. Our second guest is Dr. Kleijn, Assistant Professor of Psychology and Computer Science at Leiden University. His research includes topics such as AI, computational modeling, artificial neural networks, and cognitive psychology. So thank you very much for having both of you actually today, and I'm looking forward for your talk.
Okay, thank you. Is my screen visible to you?
Yes, I can see that.
Okay, thank you for the invite to present our research to your group. Today, Roy and I are going to talk about the predictors of human deepfake recognition. This is a scientific article that was stemming on my master thesis research, where Roy was my supervisor. And we are going to talk through some of the interesting results. So first, what are deepfakes? I'm sure you're all familiar with it, but just to give an introduction, deepfakes are AI-generated media. It can be audio, video, photographs. It's synthetic, and it makes use of neural networks that mimic a person's facial form, facial expressions, mannerisms, and voice. The technology is rapidly evolving. I believe in 2017, the first deepfake video was released on Reddit. And I think back then it was really difficult to create a highly realistic video with the technology. But well, on this day, you can just use your cell phone and give an assignment to it to deepfake a video or a picture. And it's done within a minute. So yeah, it's rapidly evolving and the quality is getting better and better. Famous persons are most likely to be deepfaked, and I believe this has two causes. So the first of the causes is that the neural network needs a lot of data to be able to learn the facial form and the expressions. And the second reason, I believe, is that it's just more interesting for people to deepfake famous persons, especially when the videos or deepfakes are being shared around the world. So this is an example video of the study we did. And well, I'm going to leave it up to you if this is real or fake. What do you think? Was this a real or a fake video?
I'll defer to Simon on that one, our resident expert.
Were we supposed to have the sound there? I think maybe you need to share your sound separately. No,
there's no sound involved with these clips.
Okay.
Okay. Well, as the resident expert, I know better than anybody that it's impossible to tell. So.
Okay, and this was a real video, and well, this is the one of the deepfake videos connected to the real video you just saw. So to me, it's already already really difficult to recognize this. Well, this video is even I think 4 years old right now. So this is another one. Any idea?
I'd say this is fake.
Yes, this is a fake one. And this is the... this one stopped working, but I was about to show you the real video. Something is going wrong with my presentation. One moment.
Fabio, what made you say that one was fake?
I don't know, sixth sense, like it just looked weird to me. It didn't look like as a very natural face, but I mean, but the first two I really couldn't tell. Like I was tempted to say the first one was real, but the second one looked real as well to me. And as Ewout said, like those are also 4 years old videos. So I mean, I suppose now it's even better.
Okay. I'm not sure why it isn't working, but I'll try continuing the present. Okay. Should be visible right now. So the research on deepfake videos is mostly focused on algorithmic detection. A few years ago, when we started the research project, almost no articles were available on the human recognition of the deepfake videos. And if so, the articles, the papers were mostly focused on, well, perceptions, but through surveys and not so much through presenting deepfake videos and real videos to participants. But we're seeing an increasing focus on the human recognition. So over the past years, there have been some interesting articles. There's also quite a connection to fake news research because deepfake videos can be used as a form of fake news. Okay. So now I'm going to present a few studies to you that were done before ours. And the first one was answering the question of can people detect manipulated photos? So this wasn't so much on deepfakes, but on photos in general. And participants had the task to detect and locate manipulations. Only 62% accuracy was scored over the sample size of 707. And what was interesting about it was that people find it really hard to detect manipulations in photos of the real world. But even when the manipulated pictures are, well, physically implausible, for example, that the shadow in a picture isn't even possible. So even when you have these kind of cues, it's still hard for people to recognize a picture. So this shows that you know, if there's a good edit of a video or a picture, people really struggle at recognizing it. Then the second article, this was a quantitative study, and participants had the task of classifying 20 videos as a real or a deepfake video using different strategies. So all the participants well, randomly got to know some strategies, such as focusing on the hair of a person that's portrayed, or the teeth or eyes, all those kinds of things you can look at when trying to recognize a deepfake video. And the interesting thing was that the strategy made no difference in accuracy. Another interesting point of the article was that human deepfake detection accuracy ranges from 58 to 89%. And I think that the reason behind this great variation in findings from all the different articles is that the technology is evolving so rapidly. So yeah, the stimuli you present participants with can be outdated the moment you publish the article. And even when we selected the videos we presented to our participants, which we will talk about later, there were just different qualities within the database of deepfake videos we used. So yeah, quality is a big issue. Then the following study was on the people's awareness of deepfake videos. This study was done in India, and I believe with people from the city, but also with people from the more rural areas. And some of the interesting points on this study were that people expect fake videos to be of a low quality, and they actually underestimate the quality of deepfakes we have nowadays. And thereby also they underestimate technological advancements of the fake videos. Then something that I found pretty contradicting was that first, they don't expect acquaintances to share fake videos on social media. So whatever an acquaintance shares to you must be true. But at the same time, they sometimes share videos that they know are fake, but fit into their worldview. So this was a really interesting point to me. And then something about the familiarity with persons portrayed on a deepfake. I already mentioned that most of the times it's famous persons that get deepfaked. So this study looked on the effect of familiarity, and being familiar with a person portrayed is associated with a higher detection accuracy. Another takeaway from this study was that humans rely on a small number of cues when assessing the videos, and mostly they are looking at the face and not so much on the surroundings. Then we found some interesting articles on fake news recognition, mostly focused on conspiracy mentality and social media usage. It was a study with over 1,000 participants. And it was on how people that are exposed to fake news come to believe in them. So for conspiracy mentality, it showed that people with a higher conspiracy mentality are more likely to share and believe fake news. And people that spend much time on social media are likely to believe less in fake news. So our study was focused on the predictors of human deepfake detection performance. So not so much on the performance in general, as we have seen in the previous studies. And we looked at the conspiracy beliefs and social media use because of the fake news article that showed that as important predictors. We also looked at the effect of age, gender, and familiarity with the stimulus. Well, with the question of, do people share deepfakes because they don't recognize them as such, or are there underlying factors at play? So our method consisted of presenting a Qualtrics questionnaire to over 100 participants. In this questionnaire, we built in a conspiracy mentality questionnaire, which Roy will talk about in the next slides. And also almost 170 videos, of which 59 were authentic videos of celebrities, just like I showed you, and 115 deepfake videos corresponding to the authentic videos. We used the videos of the CelebDF dataset. This was a dataset of researchers that tested deepfake detection algorithms on deepfake videos. And we were able to use those videos for our study. Average length of the videos was 13 seconds, and there was no audio involved. And the best performing participant of our study got a bonus for the best performance. Okay, Roy, the floor is yours.
Thanks, Ewout. Thanks everyone for having us. Like Ewout already introduced, I was Ewout's supervisor for his master's thesis, and this is basically the product of what came out of that project. So yeah, conspiracy mentality. Belief in conspiracies seems to be correlated between conspiracies. So if people believe in one conspiracy theory, and quite some research has been done on this. For example, if you believe that 9/11 was a conspiracy, then you're also likely to believe that for example, aliens exist. So these are all theories that don't necessarily content-wise seem similar to each other, but it seems to reflect some kind of mistrust of authority, or at least that's what some theories would say. Conspiracy mentality tries to measure general belief in conspiracies, of course. So 5 statements that people can agree to or disagree with on a scale from 0 to 100. For example, government agencies closely monitor all citizens, and many important things happen which the public is never informed about. And I guess you can all see how these statements can kind of capture this general conspiracy mentality that could explain this correlation between belief in different types of conspiracies. Oh yeah, you have the control still, Ewout. Can you go to the next slide? Thanks. So because of a lot of these deepfake videos are shared on social media, we also wanted to see how social media use would be associated with being able to detect deepfakes. It relates to the question: do people share deepfakes because they truly believe what is in there? Or do they have some other nefarious reason to share them? And the idea would, of course, be that exposure to deepfakes would perhaps increase the ability to detect deepfakes. So these are just some questions we came up with ourselves. This is not a standardized. This is not an existing questionnaire. It's just how many types of social media do you actually use? How many hours a week do you use social media, and how often do you post, and how many contacts do you have on social media? And you see this, at least in our sample, we saw this huge spread of social media use, with one participant indicating that they would use social media for 70 hours a week. Yeah, these are pretty extreme scores. Thanks, Ewout. Can you go to the next slide? Yeah, so if you're interested in studying how good are people at detecting deepfakes, it's important to think about some kind of metric that you want to use. And of course, most intuitively, you would say, well, accuracy is a good metric, right? Because you can just basically count the percentage of answers that are correct, but that doesn't really work for unbalanced data sets, right? So if, for example, 90% of all the videos that you show are authentic videos, and everyone would just always answer authentic, then they would have an accuracy that is extremely high. So most often in machine learning, we would use an F1 score, but that also has some disadvantages. For example, it is sensitive to class swapping. So if you call something a positive or a negative, it changes the F1 score, and we ended up with the Matthews correlation coefficient as a good metric of performance, with 1 indicating perfect classification performance and -1 indicating, well, basically answering all the items incorrectly. The Matthews correlation coefficient uses all 4 classes, so true and false, positives, and negatives. It should be noted that the correlation between the MCC and the F1 score is actually quite high. So here's the confusion matrix. When we look at classification performance for our sample, and like Ewout said, we gave him bonus, and we announced a bonus for the person who was best at classifying. So they were kind of motivated to do their best. We see a sensitivity of 89% and a specificity of 66%, which is actually still quite high. I mean, the examples that Ewout just showed, I found them pretty difficult to distinguish between authentic and deepfake. But overall in our study, we had an accuracy of 80%, and I believe an average MCC of 0.62. All right. Well, looking at the predictors of classification performance, because we were not necessarily interested in classification performance per se, but what could predict classification performance, and age was one variable that we took into account. I'm sure you're all familiar with the problem of testing participants in a university setting, where most of them are actually undergraduate psychology students, and this was also the case in our study. So when you look at the distribution of ages, most of them are between the ages of 18 and 22, let's say. So I don't think we have a good sample to actually say something that is really, that's really solid about age as a predictor. But in our sample, at least, we did not find a relationship between age and classification performance as measured by the Matthews correlation coefficient. And we have a BF01 of 2.61. So these results are not too high in confidence, but we did not find a relationship there. When we compare the two genders, male and female, in classification performance, we find no significant differences, and we actually find a base vector of 3.34 that suggests that the two groups are equal in performance, so also no effect of gender on classification performance. And then we get to this, basically what we were most interested in, I guess you could say, this idea of conspiracy thinking and being able to classify deepfakes. So originally we thought, well, of course, if you would expect people to basically share deepfakes because you think they're actually authentic videos, then you would expect a negative relationship here. But this is not what we found. We actually found this positive relationship where people who score high in conspiracy mentality also are able to better distinguish between authentic and deepfake videos. Corresponding to a small to medium effect size, we don't really have a solid understanding of why this is the case. We have some hypothesized explanations, like people that score high on conspiracy thinking, they are more skeptical, they look more critically to information that they get, but we did not test this further, which might be a future avenue for research. Yeah, and then we look at social media use as a predictor of performance. So earlier studies have shed some light on social media use and fake news. And I guess you could see deepfake videos as a special form of fake news. And here we find a positive relationship between social media use as measured by the hours per week spent on social media. We used several measures when Ewout showed the questions earlier that we used to determine social media use. Hours per week spent on social media has a positive correlation with a deepfake classification performance. At first, we thought, well, if you look at the scatter plot right here, it may be that this outlier at 70 hours a week is the main cause for this significant correlation. But even if you remove the outlier that you see at 70 hours a week, the results don't change. There's still a positive relationship between the two measures. There are also these other measures that we used for social media use, namely the number of different social media platforms used, how many posts a week they publish, and the number of social media contacts. But we did not find solid effects here. Specifically, when you look at the base vector, we can, I think with some confidence, say that the number of social media contacts is not related to classification performance with a base vector of 3.9. And I think we are underpowered to answer the other two questions, the number of different social media platforms and the number of published social media posts. And then finally, as well, to be a bit in line with earlier papers written on this topic, stimulus familiarity as a predictor of performance. It seems intuitively plausible that if you are more familiar with a person who is starring in a deepfake video or an authentic video, your accuracy would be higher. This is something that we tested using a cross-level logistic mixed effects model, where we introduced random slopes for participants and the different stimuli. And there we find, if we compare the full model with the model without familiarity as a fixed effect, we find a significant difference. And when you look at the point estimate for familiarity being 0.81, This suggests that that there's a 124% increase in the odds of correctly identifying a video for familiar persons when you compare it to unfamiliar persons. And here the dependent variable was accuracy because, well, of course, the Matthews correlation coefficient is a group statistic, and you can't really do these analyses on this. So here we used accuracy as a classified binary 0, 1. So knowing what we know or what we have found, the question then remains, well, what are we supposed to do with this? So if you look at each generation of deepfake evolution, I guess you could say, they're getting better and better. It's getting harder and harder to distinguish real from fake. And this is something that Ewout and I discussed as well, because of course we would like to continue this line of research. But as we were discussing between the two, well, where do we go from here? When you look at these newest videos that OpenAI published, we're like, well, we find it very, very difficult to distinguish this. And I guess you can still see some minor mistakes where generative models now struggle with, for example, hands, for example, or text or small details. But overall, it's getting harder and harder, and we're not really sure where to go next. When you look at the impact that this has, right? This idea that deepfakes are no longer really distinguishable from authentic videos. Where does it go in terms of protecting the population? Do we have some kind of do we need to train people to detect deepfakes? And this is what you see a lot in the literature on fake news. We need to make people resilient against misinformation. But where would you go? What would you do? And we think, well, training people to specifically detect deepfakes is not really helpful if deepfakes are changing every generation and they're getting more and more difficult to distinguish from real. Maybe we should take a step back and focus more on training against misinformation in general, making people more skeptical about what it is that they're seeing. Maybe that helps. But yeah, we don't really have clear answers on where to go next, and I think this would be a good topic to discuss with you guys and how you look at this. And thank God that your resident deepfake expert is here, because I would like to hear their opinions on the matter as well. Is this everything we have, Ewout? Okay, well then I hope we can open a fruitful discussion to talk about, well, the future of deepfakes, but specifically also the future of deepfake research.
Thank you very much to both of you. And well, yes, we have plenty of time for discussions. So let's see if we have some questions already from the audience.
I do have one. I'm afraid I can't work out how to put my hand up at the moment, but I'll do it in real life.
Okay.
So an observation.
You want to stop the recording? Sorry to butt in, but we typically stop recording for the questions.
Sure. Oh, well, actually we don't, but...
Oh, don't we? Sorry, then I'm mistaken. Okay.
At least I know. Okay.
Keep it rolling.
I can stop the recording depending on the questions. I mean.
I'm happy. It's just I thought we always did that, but maybe I'm just...
No, actually we don't. So if that's okay, I'll leave it rolling. So Simon.
I'm ever so sorry, but actually someone just knocked on my door, which I really need to answer. So can I come back for the next question?
Sure, yes.
Okay, well, in that case, maybe I can ask a question or make a few comments. I think it's very interesting, and it's a very interesting idea to get these individual predictors, right? I mean, that's really cool. But the results are amazing. I mean, the fact that CMQ predicts better performance is wow. I kind of find that amazing. And I'm wondering, if you've looked at other potential outcome measures, you mentioned the F1 statistic, but then did you ever look at that, for example? And do you get the same outcome with that?
Yes, we actually looked at F1 performance as well, and we also found a significant relationship with F1 score. But
Okay.
in the end, we decided that, well, like I said, it was a bit of a discussion which metric we would use, F1 or MCC. In the end, we used MCC because, well, there are some criticisms about F1 score, even though it's the most widely used metric, of course, in machine learning. But we do find a relationship between conspiracy thinking and F1 score as well.
Okay. And what about some sort of criterion measure? Independent of accuracy, have you looked at that? Sort of the propensity to call everything fake.
Well,
is that
we also
effective?
we did some separate analyses where we looked at classification performance both for authentic videos and deepfake videos, and we did not find a significant difference there.
Yeah, but but what about the CMQ result? Does that hold for both types of stimuli?
That's a good question. We did not run this analysis.
Okay. Because I mean, one of the things that characterizes people high in CMQ, in my experience, is that they'll see a conspiracy everywhere, and hence, they might say, "Oh, that's fake. That's fake. That's fake. Everything is fake." Now, that shouldn't really explain your data if you're using the measure that's not contaminated by the imbalance number of the two different types of. It would still be interesting to just look at some sort of criterion effect, in a signal detection framework. Just look at criteria as well. And on that, the other question I have is: did you take confidence ratings at all, or was it just a yes, no kind of, or fake, true? Yeah.
Yeah, there were no confidence ratings. This was just a binary answer.
Okay. Thank you.
Well, Simon.
Okay. I mean, my first sort of comment and question is that your participant seemed to have done much better at this than most studies. Do you agree with that interpretation? In terms of being able to distinguish?
I'm not too sure. I think we found a lot of papers that showed accuracy, at least if you talk about accuracy scores, around 70 or 80%. Is that correct, Ewout?
Yes, that's true. So we have this slide with the former research. Oh, no, it has stopped sharing. I'm sorry. Still need to get used to Zoom, but let me quickly try to grab the slides again. But I believe it was between 67% and 89% in most studies.
Yeah, I mean, when you look at the higher numbers in that, they're unsurprisingly, they're the earlier studies. And also some of those studies were using videos which were almost comical in how simple they were. They were kind of things like a static head pasted over someone's body. So that's why you get the 88.9%. My take on it when looking at what I would regard as a proper kind of realistic deepfake is that you're down much nearer to well, I thought actually 52, but okay, even if we say 57. And to be honest, the range of accuracy, if you look at those studies, is almost entirely down to the quality of the deepfakes that they use to do it. So one of the things that really interests me about what you've done is the fact that you didn't use audio. And I wondered if you have considered whether that actually enhances people's ability to spot minor defects in the video.
Yeah, I agree that adding audio would I think would make the study more interesting. But we ran into some problems finding comprehensive annotated deepfake data sets. that, like you said, were not comically easy. And when we looked at several of these data sets, the CELAB-DF data set basically were, at least at that moment, when I think 2 or 3 years ago when we started the study, was I think most difficult to distinguish deepfake from authentic, but with the disadvantage that it didn't have audio. Ewout, do you remember the thinking process?
Yes, that was one of the reasons, but the other one was that if you use audio as well, it sort of gets contaminated with the content of the audio.
Yeah. I mean, I'm not saying you should have used audio. What I'm saying is actually what you've done is create a really interesting hypothesis, which is that without audio, people are more able to spot the inconsistencies in the video. Because if you're watching a video of a famous person and their voice is very realistic, perhaps that's enough to fool you when you don't look that closely at the video. So it might be the case that the reason that your participants have done so well is that their eyes are entirely on the video, and therefore they're more likely to see those tiny little differences. I mean, I just think that would be a really interesting thing to find out if that's the case.
Yeah. I mean, absolutely. It suggests an immediate experiment, which is to fully cross, video and audio. Is it both there and none? Well, you can't do none. That's nothing. But, you can look at the audio alone if it's a famous person, or the video alone, or they're both combined, and see if there is something to that. And it would be very interesting if the absence of audio is boosting people's performance, right? Because it's sort of a little bit counterintuitive, I guess.
Yeah, it sounds like a cool hypothesis. It didn't even cross our minds, but it sounds plausible on the face of it that that being distracted by audio reduces detection performance. Yeah.
Okay, thank you. That was thank you.
No, you go, Simon. You go.
No, that's it. I'm done. Thank you, Steve.
Oh, okay. Then can you a bit more about the strategy issue here? You said, for example, you told people to look at the hair or the hands or something, I think you said. Can you tell us a bit more about that intervention, and perhaps then also speculate on why it didn't make a difference?
Can you repeat the last part of your question? I didn't properly understand.
Oh, well, tell us more about what strategies exactly you told people to use in this intervention. Or did you not tell them? I thought that was an experimental intervention where you told them what to do, or was it just you listening to them and what they told you what they did?
So this wasn't part of our study. This was an earlier study in which they taught the strategies to the participants randomly.
Okay, so it was an intervention. All right, fine, but it had no effect.
No, it had no effect. And to me, it's quite surprising, because if you focus at specific parts of the face, for example, then yeah, for me, it becomes easier to spot if it's a deep fake or not, especially the eyes, or I think the teeth are also quite clear usually. But for some reason, they did not find an effect for this strategy.
Okay, yeah, interesting.
Yeah, interestingly enough, I know someone who works at the Dutch military, and they struggle with deepfakes as well. And I think 2 years ago they incorporated the rule to ask people in live meetings to put their hands right in front of their head in order to confirm that it's a real video.
Oh, okay. And Yeah, that's so why? Sorry,
Oh
what's
yeah,
the
so the reason to do so is so now we're talking about live videos. Well, most of the deepfake videos are generated in advance, but the reason why they did it is that they were scared of being deepfaked in live video, and when a person does this, then it's harder for the algorithm to keep the video.
Oh, I see. So right. Okay.
So that's an example of a strategy that's being used
Yeah.
in practice. But again, this is with live videos, so it's somewhat different.
Right. Okay. But I take the point. Yeah, that's pretty good. So the next stage is to get people to do all sorts of complicated things with their fingers that the software can't do yet. Right. Very interesting. Okay.
Simon.
So I just thought I'd respond in terms of your question about what you think would come next. I mean, there's a couple of things that jump out at me. So our work has looked predominantly at warnings and whether they're effective. And the bottom line is they're partially but not entirely effective so far. So there's a couple of other things that I think at this stage would be really interesting to test. One is the difference between a face swap deepfake, which is presumably what those ones that you've been using, and an entirely AI generated fake. Because I don't think when you're talking about things like looking at the eyes, looking at the teeth, that kind of thing, I think if the deepfake is AI generated from scratch, I'm not sure if those sorts of things are so obvious. And to be honest, given that that's the case, my argument really at this point would be that I personally don't think there's a huge amount of mileage in continuing down the road of seeing how well people can spot them. I think you're on diminishing returns. I mean, I started doing this in 2020, and I even at that point thought this isn't really the way to go, because we're just, whenever you make any progress, it then disappears within a few months. And the deepfake that we used for our most recent study, which is just being published now, was made in 2021 and already looks incredibly old-fashioned. So I think really at this point that it would be interesting to see how much difference it makes having them AI generated. But I think the future of deepfake research is more in things like how do we control them? How do we warn people about them? How effective are those controls and those warnings? And also probably in sort of addressing the fact that there's been this kind of conflation of transparency with responsibility. So in other words, the social media companies are saying, well, we're going to tell you it's a deepfake and that's our job done, when the evidence doesn't really suggest that that is a sufficient deterrent.
Yeah, I definitely. Oh, sorry.
No, I was just going to comment on the training issue. I mean, the problem, of course, as with anything else, is that you're trying to hit a moving target. By the time you train people how to recognize the current generation, because there's a twitching earlobe in it or God knows what, they will have fixed that. And then, it's a constant catch-up game. And I don't know if there is anything sufficiently generic that will necessarily allow you to train somebody. I mean, I don't know. I'm a little worried about that.
Yeah.
But
So,
I mean, since in a sense the proof is in the pudding, you could do a training study where you train people on different generations of software. So you're looking at the sort of evolution of the technology vis-a-vis whatever training you can offer. And if people get worse at it over time, then you can draw a growth curve and you can speculate about how much longer it'll be before they're no longer trainable, right? assuming it progresses along the same trajectory. And in fact, I would be very interested in seeing the temporal evolution in the data from before, where you have the variance in detection performance, and everybody sort of agrees, yeah, that was the old stuff. But it would be nice to actually see it plotted over time, right? To see how systematic it is and how much scatter there is. And my guess is that it's pretty systematic because the technology is, improving by leaps and bounds. And yeah, I'm not sure we'll ever catch up, to be honest.
I think what that means is that really at this point, we need to be treating deepfakes in the same way that we treat any kind of misinformation. So we're talking about things like source credibility and, people's discernment in terms of content, stuff like that, rather than focusing on the actual quality of the video itself.
Definitely.
Yeah.
Sorry, what?
Go. No, you go.
I think a very interesting topic to study would be how do, for example, training programs or warnings that are more specific, how effective are they? So if you talk about a training program on recognizing misinformation in general, like focusing on sources or whatever, does that lead to better, deepfake detection performance than specifically training for that specific ability? So being able to recognize a deep or a fake newspaper article, does that generalize to labeling other types of misinformation?
Yeah, I mean, we've done something quite similar to that. It's not quite the same, but we did test a generic deepfake warning versus a specific one. So in other words, the difference between telling somebody you should just generally be aware of deepfakes when you're watching the video you're about to watch, which is incidentally kind of what they do in a court of law now. And then there's saying the video you're about to watch has been specifically identified as fake. And we actually found that it didn't make that much difference. So in other words, if you alert someone to the possibility of something being fake, they're more than likely going to think, oh, well, it probably is because I've just been told that. I mean, if they were told a month beforehand, I suppose that might be a different story. But this is a really interesting finding, but also quite worrying in the sense that if this is how we're going to approach things in a court of law, then what you're effectively doing is introducing reasonable doubt across every piece of video evidence. So the effectiveness of these various different types of labeling, I think, is probably the future of deepfake research personally.
Yeah, that is a very interesting finding. Absolutely, yeah.
Well, we have 10 minutes left, but it seems like we are kind of exhausting the discussion, at least at the moment. So if there aren't any further questions, maybe we could wrap this up a little bit earlier than usual, considering it's lunchtime for someone. Scary places to end. Yeah. It's like we are doomed, basically.
Yeah.
Just to open an invitation to you guys.
We have a talk on deepfake. I was going to say the next time we have a talk on deepfakes, we'll no longer know whether any of the people attending are actually real. I think that's my worry. We'll have some robot, some avatar giving the talk, and other avatars asking questions, and we won't know who's real.
I saw
my boss. I'll never go to a lab meeting again.
I saw an absolutely genius Zoom call on YouTube where it was a bunch of 18-year-olds in an A-level class, and one of them had joined the Zoom call as one of the other students in the class. So effectively, there were two of the same person, one real and one fake, and just saw how long it took his classmates and the teacher to work this out and try and ascertain which one was the real one.
Wow, cool. I mean, scary. Yeah, let's end before it gets to be even worse. So, well, thank you so much. That was great. Very interesting.
Yes.
Just,
Thank you
just
for
also, finally, before we go, just to extend an invitation to you both to get in touch if you want to chat about any of this or what happens next kind of thing.
That would be very, very nice. Yeah, let us give us some weeks to think about possible future avenues for research, and we'd be glad to reach out to you.
Fantastic.
All right.
Bye.
Cheers,
Yes.
guys.
Thank you very much again to both of you, and I'll see you all next week. So thank you very much. Have a nice weekend.
Bye.
Thank you. Bye
Bye-bye.
bye.